Okay, welcome back to the Algebra 2 Chapter 1 Test Review Example sheet. We're looking at problems 21 and 22. And we're going to start here by getting the absolute value part of it isolated. Well, you can see it already is on this problem. There's nothing around it. So as soon as you have it isolated, then you break this up into two copies of itself with the word or in between. And you simply solve both sides here. So we're going to add 3 to both sides, which makes the 23 into a 26, and then you divide by 4 on both sides. So your first answer is 6.5, and we have to check that answer. So we're going to take 6.5 and we're going to put it in there in a second, okay, and check it. But we'll come back and do the checking in a minute. The other side, you multiply by -1. That's the routine process we do here. And distribute, you get negative 4x plus 3. Subtract 3 from both sides to get 20. Divide by -4 to get -5. So we're going to go back here and we're going to check these answers, starting with the 6.5. 6.5 times 4 is 26. 26 minus 3 is 23, and the absolute value of 23 equals 23. So that worked out just fine. We're going to indicate that by putting a little check mark next to it. And then on the other one, we're going to put a -5 in and see how it works. 4 times -5 is -20. -20 minus 3 is -23, and the absolute value of -23 equals 23. So this 5 checks out just fine. Both of those answers work. Okay, I've got a more complicated problem over here. And that first step is not done for us. We have to isolate the absolute value part. You got to get that part all by itself. So you're going to start by subtracting 5 from both sides, and that makes the 13 here into an 8. You're not allowed to distribute, so once you get down to this line here, you have to divide by -2 on both sides. And you can see I divided this -2 to get a 1 right here. -2 over -2, and 4 over -2 to get this -4. Then once you got the absolute value bar all by its lonesome, that's when you split it up using OR. So you can see the two copies of the previous line with the bars gone. And the one on the right, I'm going to multiply by -1. That's the process you do. Okay, so get your x's on one side, and that gives 2x. -4 with a 2 joining it from the other side gives -2. This left-hand side simplifies to 2x. This side simplifies to -2. And you end up with a -1 for the answer. Now later when we check it, I think we're going to find that answer is not a good answer. Okay, so this other side here, you distribute the -1. Then you're going to bring all your like terms over, your x's over to the other side here, and anything else goes over. So -3x minus x is -4x. And the -4 minus 2 is -6. Divide both sides by -4, and you get 3/2. Or 1.5 if you prefer. So now we are going to check this -1. If I put a -1 there, I'm going to get 15 on the right side. If I put a -1 there, 3 times -1 is -3 minus 2. This would be -5. Turns to +5 when you take the absolute value. 5 times 2 is 10. And 5 minus 10 is -5. The other side, we got 15. So they're not equal, and that's why that's an extraneous answer. Okay, now we're going to take and try the other answer, 3/2. When you put 1.5 in right here, Oh gosh, you get 3 times 1.5 is 4.5. 4.5 minus 2 is 2.5. Absolute value makes it 2.5. 2.5 times 2 is 5. 5 minus 5 is 0. So we get 0 on the left-hand side. This side over here turns out to be negative 3 plus 13 is 10. So 0 on one side equals 10 on the other is definitely a false statement. And we know we have an extraneous answer there.